j 2 pi k qn by n. N cancels out. Summation k equal to 0 to n minus 1 e power j 2 pi k q is equal to summation k equal to 0 to n minus 1 e power j 2 pi q whole power k. So what is this value? In the previous properties I told e power j 2 pi n is 1. Irrespective of any value of n, e power j 2 pi n is 1. So summation 1 power k over the range k equal to 0 to n minus 1 is n. So this summation will become n. So similarly, summation p equal to 0 to n minus 1 y star of p. So I am replacing p with qn minus m plus n. So that is n minus m plus qn. So this can be written as n minus m comma modulo of n. That means n minus m of n. So replacing that, n cancels out, summation n equal to 0 to n minus 1 x of n into y star of n minus m n. What is this? Cross correlation formula. So we started from RHS and we proved LHS. Clear? So let us recall all the properties what we have studied. Periodicity property in time domain as well as in frequency domain. If the input signal is periodic, discrete time signal is periodic, then the frequency domain output signal x of t is also periodic. Similarly, linearity property, time reversal, circular time shift. So all these properties are useful in solving the problems. Okay. All these properties we will be using in the problem solving. Okay. So some useful relations which will be useful in the computation of DFT and IDFT. See here, this one, x of k equal to 0. That means x of k, what is the formula for x of k? What is the formula for x of k? What is the formula? X of k is equal to summation n equal to 0 to n minus 1. See, I am writing on the board. Summation n equal to 0 to n minus 1. What is the formula? X of n e power minus j 2 pi n k by n. This is the formula to compute DFT. Okay. So this is nothing but capital X of k. So when k equal to 0, what happens to the formula? So e power 0 will be 1. E power 0 will be 1. So x of k equal to 0 is nothing but sum of all terms in time domain. Sum of all terms in time domain. So x of k equal to 0 is summation of x of n, which is quite useful in solving DFT. Similarly, when k equal to n by 2, when k equal to n by 2, what happens here? When k equal to n by 2, n cancels out. So your formula will be 2 cancels out. So now your formula will be e power minus j pi n k. E power minus j pi n k. What is the value of e power minus j pi n? Irrespective of any value of n, e power minus j pi n will be minus 1. So minus 1 whole power k. So to compute x of k equal to n by 2, summation n equal to 0 to n minus 1 whole power n x of n. You can write either minus 1 whole power n or minus 1 whole power k. Anything is no problem. Here I am writing minus 1 whole power n x of n. So in computing DFT, first value is nothing but no need to compute DFT. This is a shortcut to calculate DFT without using the conventional formula. If you want to compute the first value of DFT, the first value of DFT will be sum of all values in x of n. And if you want to compute x of k equal to n by 2, that is middle value. Let us say n equal to 8. X of k equal to 4 will be alternate minus plus of x of n. So these things will be useful in computing DFT very quickly. You can recheck your answer. So 8-point DFT is given to you. You need to compute 8 values. It consumes a lot of time. So you need to verify whether my answer is correct or not. You can verify for these 2 values. X of k equal to 0 will be sum of all values. X of k equal to n by 2 will be alternate minus plus. So I will show you. See here. I will show you. See if x of n is given to you. X of n is given to you. Its value is 1, 2, 3, 4. Now you are asked to compute the DFT using conventional formula. So using conventional formula, x of k is already known to you. So what is the first value? First value, according to our shortcut, we can use these tips. Okay, according to our shortcut tip, x of k equal to 0 will be 1 plus 2 plus 3 plus 4. So what is its value? 10. So though you compute using the formula, you will get the same answer, 10. You can verify. You can verify whether your answer is correct or not. Next one, x of k equal to n by 2. That is here x of k equal to 2. Here n is 4. Here n is 4. So x of k equal to n by 2 means x of k equal to 2. X of k equal to 2, how do you compute? Minus 1 whole power n x of n. Minus 1 whole power n x of n. So when n equal to 0, its value is minus 1 whole power 0 is 1. So 1. When n equal to 1, minus 1 whole power 1 is minus 1. So minus 2. Alternate minus plus. So 1 minus 2 plus 3 minus 4. So what will be its value? Minus 6 plus 4. Its value is minus 2. No need to compute. Okay, without computing you can get the answer. So these things already you have seen. X of k is equal to 1, 2, 3, 4. See, x of n is equal to 1, 2, 3, 4 already you have solved. In the previous class I have shown you. X of n is equal to 1, 2, 3, 4. Okay. See here, this is one more problem. Consider the length of the sequence. 6-point sequence is given. You are asked to evaluate the following function without computing DFT. These kind of problems were asked in the previous exam. X of k equal to summation n equal to 0 to n minus 1. X of n e power minus j 2 pi n k by n. Where k ranges from 0 to 5 because length is 6. 0 to 5. So without computing DFT means you need to replace k with 0. That means summation n equal to 0 to 5 x of n e power 0. What you will get? 1 minus 2 plus 3 plus 0 minus 1 1. So you will compute, you will get 2. Next, x of k equal to n by 2. That means x of 3. So alternate minus plus. Minus 1 whole power n x of n summation n equal to 0 to 5. You will get 4. So without computing DFT, you can use these formulas. Next, one more formula. So many other formulas are also available to compute the IDFT also. To compute the IDFT. X of n equal to 0. Small x of n equal to 0. If you want to compute IDFT for a given sequence x of k, the first value of x of n will be 1 by n summation of all values of x of k. 1 by n summation of all values of x of k is first value of x of n. Similarly, for the, x of n equal to n by 2 will be 1 by n alternate minus plus of x of k. 1 by n alternate minus plus of x of k. Similarly, one more formula which is obtained from the Parseval's relation. If you are asked to compute the energy of a signal, energy of signal in discrete domain is summation n equal to 0 to n minus 1 x of n whole square equal to 1 by n summation k equal to 0 to n minus 1 x of k whole square. Okay, you can use this formula to compute the signal energy. Okay, let us see one problem. The same problem I am taking. You are asked to calculate the sum of all values of x of k. Sum of all values of x of k will be equal to what? Now, just now we have seen the formula. Sum of all values of x of k will be what? This is sum of all values of x of k. X of n equal to 0 is 1 by n into sum of all values of x of k. So sum of all values of x of k will be n into x of 0. N into x of 0. That is capital N. Capital N into x of 0. See here. IDFT formula. X of n is equal to 1 by n summation x of k e power j 2 pi n k by n. Now keep n equal to 0. This term will be 1. Sum of all values of x of k will equal to n into x of 0. That is n is 6. X of 0 is given as 1. So 6 into 1, 6 into 1, 6. So in this problem, no need to compute DFT. Without computing DFT, we are able to solve sum of all values of x of k. Similarly, square values of x of k. Square values. Sum of squares of x of k. Sum of squares of x of k. So sum of squares of x of k. Again using the Parseval's theorem. Just now I have given Parseval's theorem. By applying Parseval's theorem, sum of squares of x of k is equal to n into signal energy. N into signal energy. Using that formula, we can compute this x of k whole square without calculating DFT. So n is 6. X of n square means 1 square minus 2 square, 3 square, 0 square minus 1 square, 1 square. Total you will get 96. Is it clear? Clear? Next, few more problems we will be seeing, which are the applications of the properties. Which are the applications of the properties. So firstly you see the properties. Firstly you see the list of properties. Once again recall the properties. So these are the properties we have used. So with the help of these properties, we will be solving few more problems. Okay. Circular time shift, time reversal, circular frequency shift, circular convolution, multiplication of two sequences, complex conjugate property, Parseval's theorem, circular correlation. By applying these properties, we can solve few more problems. So these are the problems, applications of the properties. Okay. Let us see this problem. If the DFT of x of n, DFT of x of n is nothing but x of k, 4 minus 2j, 0, 2j. With the help of the properties of DFT, compute DFT of x of n minus 2. So DFT of x of n minus 2, which property we need to apply? We need to apply time shifting property. So time shifting property, recall the definition of time shifting property. So DFT of x of n minus n naught is equal to e power minus j 2 pi n by n naught k into x of k. Here in place of n naught we got 2. Here in place of n we got 4. So e power minus j 2 pi by 4 n naught is 2. 2k into x of k. That is 4 cancels out. E power minus j pi k into x of k. When k equal to 0, e power 0 into x of 0. That is x of 0. When k equal to 1, e power minus j pi into x of 1. When k equal to 2, x of 2 into e power minus j 2 pi. When k equal to 3, x of 3 e power minus j 3 pi. So what is x of 0, k equal to 0? 4. First value will be 4. What is the second value? X of k equal to 1 is minus 2j. E power j pi is, e power minus j pi is minus 1. So minus 2j into minus 1 is 2j. Next, x of k equal to 2 is 0. So 0 into any value 0. Next, x of k equal to 3 is 2j. E power minus j 3 pi means again minus 1. So j2 into minus 1. What you will get? 4, 2j, 0, minus 2j. See here, without compute. So these are the applications of the properties. First one is time shifting property application. Next one is you are asked to calculate DFT of x of minus n. Which property we need to apply here? Time reversal property. So recall the definition of time reversal property. For time, if DFT of x of n is x of k, DFT of x of minus n is x of minus k. X of minus k. So x of minus n DFT is x of minus k. X of minus k, how do you compute? X of n minus k. X of n minus k. X of minus k is also equal to x of n minus k or x star of k. Anything you can use. X of minus k, which is also equal to x star of k also. So write x of k sequence 4 minus 2j 0 2j. Apply conjugate. So for real values, the values remain same. For complex values, minus will become plus, plus will become minus. So 4 will be 4, minus 2j will be plus 2j, 0 will be 0, plus 2j will become minus 2j. So this is an application of time reversal or flipping property of DFT. Next problem, DFT of x star of n. DFT of x star of n means we need to apply conjugate property. So x of n ki DFT x of k means then x star of n, x star of minus k, x star of minus k. So DFT of x star of n is x star of minus k. Already we computed x star of k, or x of minus k. So for that again you need to apply the conjugate. So 4 minus 2j 0 2j. Here already we calculated x star. Now x star of minus k means again you need to apply conjugate. 4 minus 2j 0 plus 2j. Okay, next. Fourth problem, DFT of x square n. Which property we need to apply? Multiplication property. Multiplication in time domain is equal to circular convolution in frequency domain. Multiplication in time domain is equal to circular convolution in frequency domain. So DFT of x of n into x of n. So DFT of x of n into x of n is 1 by n into x of k circular convolution of x of k. So you know already circular convolution. In the earlier class, we have seen few problems how to compute linear convolution, how to compute circular convolution, how to compute autocorrelation, cross correlation, and similarly we have seen how to compute DFT and IDFT in the previous class. That is in the lab session. Okay. So using that circular convolution property, 1 by 4 into, you can use any method. Okay, you can follow either analytical method or circulant matrix method or graphical convolution method or DFT IDFT method. Any method you follow. Here I am using matrix method. Let us say matrix method. You remember matrix method. So you need to write like this. 4 minus 2j minus 2j 0 2j. Now you need to form the matrix, and one more column matrix will be 4 minus 2j 0 2j. So you know how to form the matrix. You need to shift 2j here. 2j 4 minus 2j 0. Again shift 0 2j 4 minus 2j. Again shift minus 2j 0 2j 4. So you need to do 3 shifts like this. In the 4th shift, you will get the original sequence again. So multiply and add them. Multiply and add them. Let us see. Let us check the first sequence. 4 into 4 16. 2j into minus 2j. That means 4 into minus j square. 4 into minus j square means 4 only. 16 plus 4 20. Again 0 into 0 0. Minus 2j into 2j 4. So 16 plus 4 plus 4. First value is 24. 24. First value is 24. Again we need to divide with n, 1 by n. So 24 divided by 4 is 6. So the first value will be, this value is 24. We need to divide it by 4, 1 by n. So you will get answer 6. Similarly, do the multiplication, you will get 6 minus 4j 0 4j. So this is you compute. This is how you compute the DFT of multiplication of two sequences. Next question. DFT of circular convolution of two sequences. Convolution in time domain is equal to multiplication in frequency domain. Convolution in time domain is equal to multiplication in frequency domain. So DFT of convolution in time domain is equal to multiplication in frequency domain. That is x of k into x of k. Here both sequences are equal, x of n, x of n. So x of k into x of k. Multiply the corresponding positions. Okay, 4 into 4 16 minus j 2j into minus 2j minus 4 0 into 0 0 2j into 2j minus 4. Okay, next one. Sixth question. You are asked to compute the signal energy. How do you compute? With the help of Parseval's relation, you can compute the signal energy in discrete domain. So the Parseval's relation is summation n equal to 0 10 minus 1 x of n whole square is equal to 1 by n summation k equal to 0 10 minus 1 x of k whole square. So 1 by 4 x of k whole square. That means 4 square, absolute value of minus 2j whole square, that is 4. 0 square is 0, absolute value of 2j whole square is 4. So 24 by 4. So the signal energy is 6 joules. The signal energy is 6 joules. Clear? So these are few questions where we applied the properties. In a similar manner, so many questions will be there. One by one we will be seeing. So this one, let us see. Let us start from this example. Okay. So here x of k is given to you. It is a 12-point sequence. It is a 12-point sequence. The first 7 samples of x of k are given. That is x of 0, x of 1, x of 6. Up to x of 6 they have given. You are asked to compute the remaining samples of x of k, which is a very useful property in computing DFT. Very useful property. What is that property? Conjugate property. Conjugate property. So x of k is also equal to x star of n minus k. X of k is also equal to x star of minus k. X star of minus k means x star of n minus k. In the previous problem lo chusam chudandi. Ikkada see here. In this problem. ఈ ప్రాబ్లంలో x of k ఇచ్చారు 4 minus 2j 0 2j. మనం ఏం కంప్యూట్ చేసాం DFT of x star of n. DFT of x star of n ఎంత వచ్చింది x star of minus k. సేమ్ సీక్వెన్స్ వచ్చింది. DFT ఎంత ఉందో అదే వచ్చింది. x of k is equal to x star of minus k. So using this property, conjugate property, x of k is also equal to x star of minus k. So using that property, x of 7 might be x star of minus 7. X star of minus 7 means x star of n minus k. So here n is 12. X star of 12 minus 7. X star of 5. So x star of 5 we need to calculate. So x of 5 is already given in the question 3 plus j. So x of 7 will be 3 minus j. Similarly, x of 8 is x star of minus 8. That is x of 12 minus 8. X star of 12 minus 8 means x star of 4. So x of 4 is given to you already in the problem. Minus 2 plus 2j. Its value will be minus 2 minus 2j. Similarly, you can calculate rest of the values. So this conjugate property is really useful in computing DFT. మీరు DFT compute చేసిన తర్వాత మీకు వచ్చిన ఆన్సర్ కరెక్టా కాదా వెరిఫై చేసుకోవచ్చు మీరు. For example, let us see this problem. X of n is equal to 1 2 3 4. X of n is equal to 1 2 3 4. ఈ ప్రాబ్లం కి మీకు DFT క్యాలిక్యులేట్ చేయమని ఎగ్జామ్ లో ఇచ్చారు. ఓకే మీరు క్యాలిక్యులేట్ చేస్తారు. మీరు చేసిన ఆన్సర్ కరెక్టా కాదా వెరిఫై చేసుకోవాలి. ఫస్ట్ ఏమైంది x of k equal to 0 ఏమైంది సమ్ ఆఫ్ ఆల్ వాల్యూస్ అంటే 10 ఆల్రెడీ ప్రీవియస్ గా చెప్పాను. x of k equal to n by 2 అంటే x of k equal to 2 ఏమైంది ఇది కూడా మీరు వచ్చిన ఆన్సర్ కరెక్టా కాదా వెరిఫై చేసుకోవచ్చు. ఆల్రెడీ వీ హ్యావ్ సాల్వ్డ్ దిస్ వన్ minus 2. X of k equal to 2. Next x of k equal to 1. X of k equal to 1 మీరు కంప్యూట్ చేశారనుకోండి. మీకు కంప్యూట్ చేస్తే మీకు a plus jb అలా వచ్చింది అనుకోండి. a plus jb. x of k equal to 3 ఏమవ్వాలి మన కాంజుగేట్ ప్రాపర్టీ ప్రకారం x of k equal to 3 x star of minus 3. X star of minus 3. X star of అంటే x star of 4 minus 3 అంటే x star of 1. ఆల్రెడీ మీరు x of 1 కనుక్కున్నారు. x star of 1 అంటే a minus jb. a minus jb. సో మీరు 4-point DFT కనుక్కోమంటే ఒక్క వాల్యూ మీరు కరెక్ట్ కనుక్కుంటే చాలు 4 వాల్యూస్ లో. x of k equal to 1 కనుక్కున్నారు అనుకోండి. x of k equal to 3 will be its conjugate. a plus jb కి కాంజుగేట్ a minus jb వస్తుంది. x of k equal to 0 మీరు కనుక్కోవాల్సిన అవసరం లేదు. సమ్ ఆఫ్ ఆల్ వాల్యూస్. x of k equal to n by 2 కూడా మీకు ఆల్టర్నేట్ మైనస్ ప్లస్ అది కూడా మీరు కనుక్కోవాల్సిన అవసరం లేదు. సో 4-point DFT లో ఎగ్జాక్ట్ గా మీరు చాలా జాగ్రత్తగా స్లోగా యాక్యురేట్ గా ఒక్క క్యాలిక్యులేషన్ చేస్తే యూ విల్ గెట్ రెస్ట్ ఆఫ్ ది వాల్యూస్. Similarly, 8-point DFT అడుగుతాడు ఎగ్జామ్ లో. 8-point DFT లో కూడా అంతే. x of k equal to 0 you can apply this rule. x of k equal to n by 2 you can calculate. x of k equal to 1, k equal to 2, k equal to 3. 3 values కనుక మీరు కంప్యూట్ చేస్తే x of k equal to 3 is also equal to x star of minus 3. That is x star of 8 minus 3. That is x star of 5. sorry, x star of 3. So x of 5 ఏమవుతుంది, x star of 3, x of 6 ఏమవుతుంది, x star of 2, x of 7 ఏమవుతుంది, x star of 1. సో 8 పాయింట్ డిఎఫ్టీలో మీరు స్లోగా అండ్ యాక్యురేట్గా 3 వాల్యూస్ కనుక కంప్యూట్ చేస్తే రెస్ట్ ఆఫ్ ది వాల్యూస్ యూ కెన్ రైట్. So these are the shortcuts which will be helpful in verifying your answer, okay, whether your answer is correct or not. Okay, next, DFT of a real signal is given to you: 1 a minus 1 b 0 minus j2 c minus 1 plus j. So how many points are there? Totally 8 points. So now you are asking, they are asking us to calculate the values of a b c. So you can apply the conjugate symmetry property. So apply the conjugate symmetry property: x of 1 a, okay, x of 1 a, x of 7 ఏమవుతుంది, x star of 1, x of 7 ఏమవుతుంది, x star of 1. So x star of 1 ఏమో minus 1 plus j, x of 1 ఏమవుతుంది minus 1 minus j, అంటే a value minus 1 minus j. Similarly b value compute చేయాలి. b value means x of k equal to 3. x of k equal to 3 is also x of k equal to 3. So x star of 5, x of k equal to 5 ఏమవుతుంది, x of k equal to 5, x star of 3, x of k equal to 5, x star of 3. So x star of 3 minus 2j అయితే x of 3 ఏమవుతుంది plus 2j. So b will be plus 2j. Next, c value ఎంతో కనుక్కోవాలి. c value x of k equal to 6, x of k equal to 6 is also equal to x star of minus 6, that is x star of 8 minus 6, that is x star of 2, x star of 2. ఇక్కడ 2 వాల్యూ ఎంత ఉంది, రియల్ వాల్యూ minus 1 ఉంది. సో దీని వాల్యూ కూడా minus 1 అయిపోతుంది. సో with the help of this conjugate symmetry property, if some values of DFT are known to you, you can calculate the rest of the values. So these tips will be quite useful in solving the DFT and verifying your answer, whether your answer is correct or not. Okay, let us see one more problem. Let x of n is equal to 8, 2, 3, 4, 5, 6, 7, b. And some data is given to you. Capital X of k equal to 0 is 20. Capital X of k equal to n by 2 is 0. And you are asked to compute AB values. Two equations are given, and with the help of those two equations, you need to compute A and B values. So two equations, two unknowns you can calculate. X of k equal to 0 is nothing but sum of all values of x of n. So you will get a plus b plus 27, a plus b plus 27. Next, which is also equal to 20 is given. So a plus b equal to minus 7. That is one equation. Similarly, x of k equal to n by 2 is alternate minus plus. So after applying that, a minus b plus 3, which is given as its value as given as 0. So a minus b equal to minus 3, a plus b equal to minus 7. So computing that, you will get a equal to minus 5, b equal to minus 2. Clear? Similarly, next problem. A, B, C values కనుక్కున్న తర్వాత సిగ్నల్ ఎనర్జీ కనుక్కోమంటున్నాడు. సిగ్నల్ ఎనర్జీ ఫార్ములా ఏంటి? Summation n equal to 0 to n minus 1, x of n square is equal to 1 by n, summation n equal to 0 to n minus 1, x of k whole square. So firstly you need to apply conjugate symmetry property, secondly you need to apply Maxwell's theorem property. So applying both properties, you can compute the energy of the signal. So to calculate the unknown coefficients, we are using conjugate symmetry property, and to compute the energy of the signal, we are utilizing the Maxwell's theorem property. So likewise, we have got many number of applications, properties applications, many problems are there. Okay. So this is one more problem. X of n is given 12 point, and you are asked to evaluate x of k equal to 0, x of k equal to 6. X of k equal to 0 is sum of all values. Doing so, you will get 13. X of k equal to n by 2, that is x of 6, alternate minus plus. Doing the manipulation, you will get minus 13. Next value, sum of all values of x of k without computing DFT. We know that this formula is equal to n into small x of n equal to 0. That is 12 into x of 0. That is 12 into 3, 36. Next value, summation k equal to 0 to 11 e power minus j 4 pi k by 6 into x of k. So this we do some mathematical work. What we do is we will multiply with 2 in the numerator and denominator. Now the function will become e power minus j 2 pi by 12 4k into x of k. So we know the IDFT formula. What is IDFT formula? X of n is equal to 1 by 12 summation k equal to 0 to 11 x of k e power j 2 pi by 12 nk. When you substitute n equal to minus 4, when you substitute n equal to minus 4, so this value will be equal to 12 into x of minus 4. This value will be equal to 12 into x of minus 4. X of minus 4 is known to you. What is x of minus 4 అంటే ఏం చేయాలి? X of n minus n. X of n minus n, that is x of 12 minus 4. X of 12 minus 4 అంటే x of 8. So x of 8 ఎంత ఇచ్చారు మీకు? Minus 4 ఇచ్చారు. So 12 into minus 4, you will get minus 48. Next, energy spectral density. Summation k equal to 0 to 11, absolute value of x of k square is equal to 12 into signal energy. You will get 1500. So this is how you compute the values without computing DFT. Okay, without computing DFT, you can calculate these functions. Okay, so with the help of these tips, you can solve many number of problems. Okay. So all of you please stay online. I am taking attendance. All of you please stay online. I am taking attendance. So B8, B9, C0, C1, C2, C3, C4, C5, C6, C7, C8, C9, D0, D1, D2, D2, D3, D4. D4 is absent. D4, D5, D6, D7, D8, D9, E0, E1, E2, E3. E4 is absent. E4, E5, E6, E7, E8, E9. E9 is absent. F0, F1, F2. F2 is absent. F3, F4, F5, F6, F7, F8. F9 is absent. G0, G1, G2, G3, G4, G5, G6, G7, G8, G9, H0, H1, H2, H3, H4, N2, LE 16, 17, 18, 20, 19, 22, 32. LE 21 is absent. Okay, you can leave the session. Thank you.